Something just happened on Titan that should not be possible. A methane sea rose, vertically, like a living wall, then collapsed in total silence. NASA instruments froze. Physics had no explanation, because buried inside that surge was a thermal signature 20 times hotter than Titan's surface, a heat source that cannot exist on an ice moon. If Titan is breaking its own laws, what else in the solar system is waking up? Before we continue, Astreon has close to 2,000 subscribers. If you enjoy space mysteries, tap subscribe and like. Now, back to Titan. The signal from Titan hasn't faded. It's getting sharper, more violent. NASA instruments aren't just confused, they're scared. The methane seas are shifting in patterns no fluid dynamics can explain, pulsing like something is alive beneath them. Something massive enough to warp Titan's crust by micrometers every hour. And now, the impossible detail from the hook is spreading through every research division. Models are collapsing, orbital simulations are breaking. A moon that was supposed to be stable, frozen, predictable, is suddenly rewriting the physics that hold the Saturn system together. Astronomers whisper about resonance spikes, tidal surges, and fractures forming in places that should be inert for another million years. Because if Titan is reacting to something, if it's responding, what exactly has awakened beneath its surface? The silence that followed the intro didn't comfort anyone at NASA. It only amplified the numbers now burning across the telemetry boards. And as the deep space carrier signal from 1.4 billion kilometers away stabilized, the truth became unavoidable. Titan was no longer behaving like a passive moon. It was responding, not metaphorically, not geologically. Responding. The continuity of the anomaly left no room for denial. Cassini's archived spectrometry, Dragonfly's newest atmospheric scans, even the Hubble UV data shouldn't have shown anything at all. They were now lining up into a pattern that scientists had no model for, because nothing in the known solar system should be emitting a thermal pulse with a fixed interval beneath a methane sky colder than -179 degrees Celsius. Dragonfly, launched in 2027 and arriving in 2034, wasn't built for impossibilities. It was built for chemistry, for organics, for slow, predictable environmental data across dunes that stretch over 1,000 kilometers. Its 8 rotors were designed to glide at Titan's 1.5 bar surface pressure, thicker than Earth's, and move through an atmosphere 98% nitrogen. Nothing in its mission profile involved tracking a repeating energy source in a world where sunlight is 100 times weaker than Earth's. Yet Dragonfly detected one. It began as a faint thermal signature buried inside the infrared noise, a spike at 11.8 microns, then another and another, every 3.9 hours. A heartbeat. NASA checked for instrumentation errors, cosmic rays, electromagnetic interference, software corruption. But the readings matched Cassini's final flyby from September 2017, data previously dismissed as a glitch because the spacecraft was spinning during transmission. The numbers were identical down to the 4th decimal place. A 3.9-hour thermal pulse from beneath Titan's crust. This alone was disturbing. Titan's interior is believed to host a subsurface ocean 100 to 200 kilometers below the ice shell, possibly mixed with ammonia. Temperatures should be stable, uniform, geologically quiet. Certainly not oscillating on a precise schedule, but the spectroscopy added a second problem. When Dragonfly passed through the pulse zone again, its mass spectrometer, designed for methane and hydrocarbons, registered something that shouldn't exist in Titan's atmosphere at all. A sudden, localized depletion of nitrogen, a measurable drop of 0.2% across a 40-kilometer region. Nitrogen does not vanish on Titan. It cannot vanish. It is not reactive in the -179 degrees Celsius environment. But for 11 minutes, a pocket of Titan's atmosphere thinned, as if something beneath the ground was pulling it inward. NASA orbital assets confirmed it. The James Webb Space Telescope, using its MIRI instrument, recorded a faint IR distortion aligned with Dragonfly's trajectory, a dip of 0.04 Kelvin in the outgoing thermal flux, a pattern consistent with a cold plume being vented downward, not upward. Downward, as if energy, pressure, movement was traveling into Titan, not out of it, and then the contradiction deepened. Cassini's gravity data, previously locked in archival storage, was reprocessed with modern algorithms. One number changed everything. Titan's gravitational moment of inertia showed a shift of 0.016%, a microscopic wobble, barely detectable, but enough to indicate internal redistribution of mass between 2004 and 2017. Moons do not redistribute mass on human timescales, not without something forcing them. If the pulse were volcanic, the nitrogen should increase. If it were cryovolcanic, thermal readings should rise and fall. If it were tidal flexing, the interval should match Saturn's gravitational cycles, 15.9 days, not 3.9 hours. But the centerpiece of the anomaly, the one detail scientists could not explain even under speculative physics, came from Dragonfly's seismometer. Titan shook. A microquake no stronger than magnitude 1.2. Barely a whisper. But the waveform contained a frequency spike that should be impossible for an icy moon. A clean, symmetric oscillation at 18.3 Hz. Titan cannot generate that tone, not with its density, not with its internal structure, not with its chemical environment. It was too perfect, too stable, too deliberate, like a signal. NASA does not claim it is a signal. The agency refuses speculation. But internally, the comparison is clear. That frequency spike closely resembles the harmonic profile of a resonating cavity, as if Titan's subsurface ocean were vibrating against its icy shell like an enormous buried instrument. If true, then Titan is not simply active, it is structured, and that breaks planetary science, because such resonance would imply internal layering so precise, so sharply defined, that no natural cryogenic process could produce it at Titan's temperature range, not within the constraints of known physics. Not without a heat source or a mechanical driver, thousands of times more stable than tidal forces. The consequences are enormous. If Titan's core is generating periodic energy, models of icy moon evolution collapse. If the atmosphere is being siphoned downward, hydrocarbon cycles must be rewritten. If internal mass is shifting, Titan's orbit, currently 1.22 million kilometers from Saturn, may be experiencing micro-instabilities no one has measured yet. And if resonance is real, then the solar system itself contains structures we do not yet understand. But the data did not stop there. As Dragonfly moved toward the western dunes, a second reading arrived. Unexpected, contradictory, more intense than the first. Something new was emerging from beneath Titan's horizon, something that would push NASA from confusion into alarm. And that is where the next shock begins. And as Titan's final signal fades into the static, the tension does not ease. It hangs there, suspended in that orange haze like a quiet warning, because whatever stirred beneath its frozen methane seas, whatever pulse moved through those hydrocarbon clouds, it has not explained itself. It has only revealed the limits of our faith in physics. Two anomalies, two contradictions. A moon that murmurs with heat where no heat should be, and an atmosphere that shifts with patterns older than Saturn itself. Together, they whisper something we are not ready to hear. Something about age, about cycles, about structures in nature far deeper than our equations allow. And suddenly, Titan feels less like a moon and more like a message. A reminder that our models are young, our confidence fragile, our understanding still an infant trying to read the sky. Because out here, beyond sunlight's reach, a single anomaly can rewrite an entire century of science. A single vibration can make us question the stability of worlds. A single chemical trace can expose the universe's oldest secrets, hiding in plain sight. So now we look again, slower, with humility. We thought Titan was predictable, but the universe is under no obligation to follow our rules, which leaves us with only one question. If Titan is changing faster than physics can explain, what else in the solar system is about to reveal itself next? Subscribe for more cosmic documentaries.